Good morning, students. This is Savita, working as Associate Professor in the Department of Mathematics. In this video, I am going to discuss matrices, which is used in finding the solution of simultaneous algebraic equations. This video is useful for 5th semester BSc students of Mangalore University. Now, what is a matrix? A matrix is a system of m into n numbers arranged in a rectangular array of m rows and n columns, and this is called an m cross n matrix. Such a matrix is denoted by capital A, which is equal to A11, A12, A1n, A21, A22, etc. A2n. Mth row elements are AM1, AM2, etc. Amn. Usually matrices are denoted by capital letters. Okay. So this is the first row elements, second row elements, which you can see on the screen, and mth row elements. So this matrix has m rows and n columns. Therefore, the order of this matrix is m cross n. This is also denoted by the symbol square brackets ಒಳಗೆ a suffix ij ಅಂತ ಬರೆಯುವುದು, which denotes ijth element of this matrix. I stands for ith row, j andre jth column. Okay, so there are m rows and n columns. So we have a matrix of order m cross n. Now let us understand special matrices. Different types of matrices. Okay. Now what is a row matrix and a column matrix? A matrix having a single row is called a row matrix, whereas a matrix having a single column is known as a column matrix. What is a square matrix? A matrix having n rows and n columns is called a square matrix. A square matrix is said to be singular if its determinant is equal to 0. Otherwise, it is called non-singular. Now, third matrix is unit matrix. A diagonal matrix of order n in which all the elements of diagonal are equal to 1 is called a unit matrix. That is, a diagonal matrix of order n which has unity for all its diagonal elements is called a unit matrix of order n, and it is denoted by the symbol I suffix n, capital I suffix n. Next matrix is a null matrix or a zero matrix. If all the elements of a matrix are 0, then it is called a zero matrix or a null matrix. Next type of matrix is a symmetric matrix and a skew symmetric matrix. A symmetric matrix is a square matrix. Square matrix andre number of rows matte number of columns same irtade. A square matrix is said to be symmetric if Aij is equal to Aji for all Inj. That is, ijth element is equal to jth element for all Inj in a square matrix, then we say that such a matrix is symmetric. For example, consider a 3 cross 3 matrix A, B, G, B, B, F, G, F, C. Okay. Now diagonal elements are A, B, C. Now look at this element. The second element of the first row is equal to the second element of the first column. So B matte B coincide ಆಗ್ತದೆ, G matte G same ಇದೆ, F matte M, F. So this is an example of a symmetric matrix. If Aij is equal to Aji for all Inj, then such a matrix is known as a symmetric matrix. Okay. Whereas, if Aij is equal to minus Aji for all Inj in a square matrix, then such a matrix is called a skew symmetric matrix. Now let us consider this example. Plus addition condition is all the leading diagonal elements are equal to 0. Symmetric matrix ali AJI is equal to AJI for all INJ. Matrix square matrix ಆಗಿರಬೇಕು. Whereas in a skew symmetric matrix, Aij is equal to minus Abi for all Inj, so that all the leading diagonal elements are 0. Okay. Now observe this. H ಮತ್ತೆ minus H ಇದೆ. ಇಲ್ಲಿ G ಇದ್ರೆ ಇಲ್ಲಿ minus G ಆಗ್ತದೆ. ಇಲ್ಲಿ F ಇದ್ರೆ minus F ಇದೆ. ಮತ್ತೆ ಲೀಡಿಂಗ್ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ 0 ಇದೆ. ಅಂದರೆ ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ಈ ನೀವು ಡಯಾಗ್ನಲ್ ಆಗಿ ಫೋಲ್ಡ್ ಮಾಡಿದಾಗ ಇದು ಕೋಯಿನ್ಸೈಡ್ ಆಗ್ತದೆ, ಎಲಿಮೆಂಟ್ಸ್ ಕೋಯಿನ್ಸೈಡ್ ಆಗ್ತದೆ, ಮತ್ತೆ ಆಪೋಸಿಟ್ ಇನ್ ಸೈನ್ ಇರ್ತದೆ. ಇದು ಪ್ಲಸ್ H ಇದ್ರೆ ಇದು ಮೈನಸ್ H ಆಗ್ತದೆ, ಅಥವಾ ಇದು ಪ್ಲಸ್ G ಇದ್ರೆ ಇದು ಮೈನಸ್ G ಆಗ್ತದೆ. So this is an example of a skew symmetric matrix. Now let us understand a triangular matrix. Triangular matrix ಅಂದ್ರೆ ಏನು? Upper triangular matrix ಅಂತ ಇದೆ, lower triangular matrix ಅಂತ ಇದೆ. A triangular matrix is a square matrix, all of whose elements below the leading diagonal are 0 is called an upper triangular matrix. So this is an upper triangular matrix. Elements below the leading diagonal are 0. This is a 3 cross 3 matrix. A, B, C are diagonal elements. Elements below the leading diagonal are 0. So this is an example of an upper triangular matrix. Whereas a square matrix, all of whose elements above the leading diagonal are 0 is called a lower triangular matrix. For example, A 0 0, B D B 0, E W C. So this is an example of a lower triangular matrix. Elements above the leading diagonal elements are all zeros. Okay. Next, let us study operational matrices. Matrices ಅನ್ನು add ಮಾಡಬಹುದು, matrices ಅನ್ನು subtract ಮಾಡಬಹುದು, scalar multiplication of matrix ಆಗ್ತದೆ, matrices ಅನ್ನು multiply ಮಾಡಬಹುದು. So when to add matrices, subtract matrices and two matrices equal ಆಗುವುದು ಯಾವಾಗ ಅಂತ ನೋಡುವ. First is equality of matrices. Two matrices A and B are said to be equal if they are of the same order and each element of A is equal to the corresponding element of B. If A and B are two matrices of the same order, then A plus B, that is, you are adding two matrices A and B, their sum A plus B is defined as the matrix, each element of which is the sum of the corresponding elements of A and B. A ಮತ್ತು B ಎರಡು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಫ್ ದ ಸೇಮ್ ಆರ್ಡರ್ ಆಗಿದ್ದು their sum A plus B ಅಂದರೆ corresponding elements of A ಮತ್ತು B ಅನ್ನು ಆಡ್ ಮಾಡುವುದು, which is the sum of the elements of A and B. Corresponding elements of A and B. Okay. Similarly, A minus B is defined as the matrix whose elements are obtained by subtracting the elements of B from the corresponding elements of A. So this is subtraction of two matrices A and B, which is denoted by A minus B. Now let us see multiplication of matrices. ಯಾವ ಕಂಡೀಷನ್ ಮೇಲೆ ಎರಡು ಮ್ಯಾಟ್ರಿಸಸ್ ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬಹುದು ಮತ್ತೆ ಸ್ಕೇಲಾರ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ನೋಡೋಣ. Multiplication of a matrix by a scalar. If a matrix A is multiplied by a scalar k, then it is known as multiplication of a matrix by a scalar, which means each element of the matrix is multiplied by a scalar k. That is, each element is k times the corresponding elements of the matrix A. Now consider two matrices A and B. If A is a matrix of order m cross n and B is a matrix of order n cross p, then the product of two matrices A and B is defined and it is a matrix of order M cross P. So two matrices can be multiplied only when the number of columns in the first matrix is equal to the number of rows in the second matrices. Okay. So those two matrices are said to be conformable. If A is a matrix of 2 cross 3 and B is a matrix of 2 cross 3, then we cannot multiply two matrices A and B. So condition ಏನು ಅಂದ್ರೆ the number of rows of the second matrix is equal to the number of columns of the first matrix. Then only the product AB is defined and it is a matrix of order M cross P. Andre M is the number of rows of the first matrix and P is the number of columns of the second matrix. Okay. ಈಗ transpose of a matrix ಅಂತ ಏನು ಅಂತ ನೋಡುವ. These are all related matrices. The matrix obtained from a given matrix A by interchanging rows and columns is called the transpose of A and it is denoted by A dash. Suppose A is a matrix of order 2 cross 3. A is a matrix of order 2 cross 3, which means A has 2 rows and 3 columns. Then the transpose of the matrix A, which is denoted by A dash, is a matrix of order 3 cross 2, which implies the transpose has 3 rows and 2 columns. That is, the transpose A dash of a matrix A is obtained from A by interchanging its rows and columns. Okay. For a symmetric matrix, A dash is equal to A itself. What is a symmetric matrix? A square matrix A is said to be symmetric if Aij is equal to Aji for all I and j. Therefore, for a symmetric matrix, A transpose is equal to A itself. Whereas for a skew symmetric matrix, A transpose is equal to minus A. Okay. Now, what is the transpose of the product matrix? Suppose A and B are two matrices such that product AB is defined. Then transpose of the product AB is equal to B dash into A dash. That is B transpose into A transpose. Third condition or a third related matrix is any square matrix A can be written as A is equal to half into A plus A transpose plus half of A minus A transpose. Now, let us denote half of A plus A dash by B and half of A minus A dash by C. So, we have to show that B is a symmetric matrix and C is a skew symmetric matrix. So, any square matrix can be expressed as a sum of symmetric and skew symmetric matrix. Now, let us consider B transpose. B is equal to half of A plus A dash. Find its transpose, that is equal to half into transpose of A plus A transpose, which is equal to half into A transpose plus transpose of A transpose, which is equal to A. But A transpose plus A is equal to B itself, which means B dash is equal to B. Therefore, B is a symmetric matrix. Now, let us show that C is a skew symmetric matrix. So, consider C. C is equal to half of A minus A dash. Find its transpose. C dash is equal to half of transpose of A minus A dash, which is equal to half into A transpose minus transpose of A transpose equal to A. Therefore, this is equal to half into A transpose minus A, which is equal to minus of half into A minus A transpose, which is equal to minus C. Therefore, C dash is equal to minus C. or C is equal to minus C transpose, which means C is a skew symmetric matrix. Therefore, any square matrix can be expressed as a sum of symmetric and skew symmetric matrix. Now using this, let us solve a problem. Let us show that any square matrix can be written as sum of symmetric and skew symmetric matrix. Okay. Consider the matrix A, which is equal to a 3 cross 3 matrix. Elements are 3, minus 2, 6, 2, 7, minus 1, 5, 4, 0. Problem is to express the matrix A as a sum of symmetric and skew symmetric matrix. Okay. First find its transpose. Andre idre rows iddadu columns agtade, columns iddadu rows agutte. So interchange the rows and columns of the matrix A and write A transpose. A transpose is equal to 3 minus 2 6 are the first column elements. Second row iddadu second column agutte. So 2 7 minus 1, these are the second column elements, and third column elements are 5 4 0. Now add A and A dash. A plus A transpose is equal to, add the two matrices. How to add the matrices? We need to add the corresponding elements of A and A dash. Look at this. These two matrices are of the same order, so we can add the matrices A and A dash. So by adding the corresponding elements, we get A plus A dash. 3 plus 3 is equal to 6. Minus 2 plus 2 is equal to 0. 6 plus 5 is equal to 11. 2 plus minus 2 is equal to 0. 7 plus 7 is equal to 14. Minus 1 plus 4 is equal to 3. 5 plus 6 is equal to 11. 4 plus 4 minus 1 is equal to 3, and 0 plus 0 is equal to 3. So A plus A dash sikkitu. Similarly, find A minus A dash. Subtract A dash from A. How to subtract the matrices? Subtract the corresponding elements, isn't it? Okay, so 3 minus 3, 0. Minus 2 equal to minus 4. 6 minus 5 equal to 1. 2 minus 2, 2 minus of minus 2 is equal to 4. 7 minus 7 is equal to 0. Minus 1 minus 4 is equal to minus 5. 5 minus 6 is equal to minus 1. 4 minus of 1 is equal to 5, and 0 minus 0 is equal to 0. Okay, next step is you multiply A plus A dash by scalar half. So half of A plus A dash is there. Each element of A plus A dash is multiplied by 1 by 2. So 6 into 1 by 2 is equal to 3. 0 into 1 by 2 is 0. 11 into 1 by 2 is equal to 5.5. 0 into 1 by 2 is equal to 0. 14 into 1 by 2 is 7. 3 into 1 by 2 is equal to 1.5. 11 into 1 by 2 is equal to 5.5. 3 into 1 by 2 is equal to 1.5. 0 into 1 by 2 is equal to 0. Now similarly, multiply A minus A dash by scalar half. Multiply each element by half. So 0 into half is 0. Minus 4 into half is equal to minus 2. 1 into half is equal to 0.5. 4 into half is equal to 2. 0. Minus 5 into half is equal to minus 2.5. Minus 1 into half is equal to minus 0.5. 5 into half is equal to 2.5. And 0 into half is equal to 0. Now what do you observe? See, this is the diagonal elements. These are the diagonal elements. Aij is equal to Aji, isn't it? A12 is equal to A21. A13 is equal to A31. A23 is equal to A32. So the first matrix is a symmetric matrix. Observe the second matrix. This is a skew symmetric matrix because the leading diagonal elements are all equal to 0 and Aij is equal to minus Aji. Clearly observe that this is positive ಆದರೆ ಇದು ನೆಗೆಟಿವ್ ಇದೆ, ಇದು positive ಇದೆ, ಇದು negative ಇದೆ, but they are same, they are opposite in sign, isn't it? Therefore, any square matrix can be expressed as a sum of symmetric and skew symmetric matrix. Okay, ಈ ವಿಡಿಯೋದಲ್ಲಿ ಇಷ್ಟೇ. ನಾನು ಈ ವಿಡಿಯೋ ಪ್ರಿಪೇರ್ ಮಾಡಲಿಕ್ಕೆ ಡಾಕ್ಟರ್ ಬಿ ಎಸ್ ಗ್ರೇವಾಲ್ ನ್ಯೂಮರಿಕಲ್ ಮೆಥಡ್ಸ್ ಇನ್ ಇಂಜಿನಿಯರಿಂಗ್ ಆ್ಯಂಡ್ ಸೈನ್ಸ್ ವಿತ್ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಇನ್ ಸಿ ಆ್ಯಂಡ್ C++, ಈ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಕನ್ನು ರೆಫರ್ ಮಾಡಿದ್ದೇನೆ. ಐ ಹೋಪ್ ಯು ಹ್ಯಾವ್ ಅಂಡರ್ಸ್ಟುಡ್ matrices. ನೆಕ್ಸ್ಟ್ ಸೆಷನಲ್ಲಿ ಎಲಿಮೆಂಟರಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ಸ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದರೆ ಏನು ಅಂತ ನೋಡೋಣ. ಐ ಶಲ್ ಸ್ಟಾಪ್ ಹಿಯರ್. ಥ್ಯಾಂಕ್ ಯು.